Hello students, now we are going to start nuclear energy topic nuclear fusion for the class 12 physics and the chapter name is a nuclei. This topic is really important for the CBSE NEET as well as for the IIT JEE examination. So let's begin the first topic, fusion reaction. In nuclear fusion, two or more unstable smaller nuclei join together to produce one stable new particle. For an example, like 1H1 is breaks into two parts like fuse like He 2He4 plus 1 E0 plus 26.7 mega electron volt energy release. So if the helium nucleus like 1H1, four particles of a 1H1 is combined and makes helium. So that is called fusion reaction where smaller nuclei are combined together to produce a stable particle like a helium, four times of a hydrogen particle combined and makes the helium. The energy release is about 6 mega electron volt per nucleon and this has more energy per nucleon than fission. So energy of the new fusion is a more rather than nuclear fission. 0.7 of the total mass is a reactant is converted to the energy in a both cycle. Total energy related is 26.7 mega electron volt and the energy released per nucleon is 6 mega electron volt. In stars whose interior temperature are less than that of a sun proton cycle takes place. In stars whose interior temperature are greater than sun, like carbon-nitrogen cycle takes place. And in the sun, both cycle occurs in the equal probabilities, like what we are saying. Like in stars, interior temperature are less than, so that will be proton-proton reaction takes place. And if interior temperature are greater than, then carbon-nitrogen cycle start to takes place. Nuclear fusion is a process which energy emitted by stars. So hydrogen nuclei are fused to form the helium nucleus is a heavier element can also be formed by the fusion. So fusion reaction can take place in the sun due to the high temperature and pressure in the core. To produce fusion on Earth, you have to give nuclei very high energy to keep them closer at high temperature like 10 to the power 6 Kelvin. Hence they are called as thermonuclear reactions. Experiment designed for a nuclear fusion power plant are building built. So the fusion of hydrogen takes place by proton-proton cycle and a carbon-nitrogen cycle. Proton-proton cycle. The proton-proton cycle is an important source of energy in the sun and in a star comparatively lower temperature like red dwarf. Like when 2 times of a 1H1 plus 1H1 is combined, so 1H2 deuterium is created with some energy and because of the balancing of the charges, so 1E0 created with the some energy which is called as a neutrino. And 1H2 plus 1H1 created 2 times like 2He3 plus gamma radiation and 2H3 plus 2H3 created 2He4 plus 2 times 1H1. Four times 1H1 particle created 2 times He4 plus 2 times of energy plus some types of energy was 26.7 mega electron volt. Carbon-nitrogen cycle. Energy released in a star like sun due to the fusion of a hydrogen by carbon-nitrogen cycle and proton-proton cycle. Like C612 plus 1H1 gives out 7N13 plus gamma. 7N13 gives out 6, 6, 13 plus 1 E0 plus NT neutrino. 1H1 plus C, this gives out nitrogen 7 and 14 plus gamma. And 1H1 plus 7 nitrogen 14 is gives out oxygen plus gamma. And 8O15 gives out 7 and 15 plus 1E0 plus antineutrino. So 1H1 plus 7 and 15 gives out the carbon plus 2He4 plus cutant value. Or we can say 1H1 is gives out 2He4 plus 2 times 1E0 plus 26.7 mega electron volt. So the energy released is about 26.7 mega electron volt in both the carbon nitrogen cycle and proton proton cycle. Older stars have more helium compared to the younger ones. So carbon nitrogen cycle is a more probable in the star heavier in the temperature. Due to the enormous energy released by the sun and by the star, the atmosphere of them will be ionized. That state is called as a plasma, which contains fast moving neutrons and electrons. Nuclear fission and nuclear fusion. So neutrons are required for it, protons are required for it, or a deuteron are required for it. It is a possible at normal pressure and temperature. It is a possible at a high pressure and temperature. Energy released per nucleon is zero point 0.9 mega electron volt and energy released per nucleon is 7 mega electron volt. Percent of mass getting converted into the energy. Percent into the mass getting converted into the energy is 0.7 and fission 0.1%. Fusionable materials are expensive, fusionable materials are cheap. Now let's move with some questions. In dash, two or more unstable nuclei join together and to produce one stable new particle. The correct answer is a nuclear fusion. When fusion is achieved by raising the temperature of the system so that particles have enough kinetic energy over come to Coulomb's repulsive behavior. Chain reaction, thermonuclear fusion, fission, none of them. Thermonuclear fusion. Classification of elementary particles. So elementary particles are classified by two categories that are called as their spin value boson and fermions. Bosons are the particle with intrinsic angular momentum is equals to an integral multiple of h by 2 pi and obeys Bose-Einstein statistics. For example, photons, gravitons, mu mesons, chemosons. Fermions. Fermions are those particles having half-integral spin and obeys Fermi-Dirac statistics. Fermions are the intrinsic angular momentum is half of the integral multiple of h by 2 pi. So what is the difference you observed in both students? Like this is the integral multiple of h by 2 pi and this is the half integral multiple of 2 pi, h by 2 pi. So fermions are again subdivided into two groups depending on their masses. Like lighter fermions are called as leptons, and heavier ones are called as baryons. Particles without any internal source are called as elementary particle. Like they have without any internal structure, they don't have any structure like a spherical in nature. They don't have any shape or a colors. Proton, neutron, electrons, and photons considered as a fundamental particles. Mass, charge, spin, and magnetic moment are the basic quantities used to identify the elementary particle. Again, mass, charge, spin, and magnetic moment. These are the basic quantities which are actually need for finding or identify the elementary particles. The elementary particles are divided into four types: photons, electromagnetic interaction; leptons, weak interaction; hadrons, strong interaction; and gravitons, gravitational interaction. Leptons for a weak interaction and hadrons for the strong interaction. Photons, particle that carries electromagnetic energy, called as a photon. They possess no mass, no charge, but a spin is a 1, and they are stable. Photon can stay at rest without any reference system. Leptons, these are light particles with the spin half, do not participate in strong interaction. And a positron is the first antiparticle predicted by Dirac and discovered by Anderson. Positron combine with electron in 10 to the power minus 7 and both annihilate into the gamma radiations. The rest mass energy of the positron is equals to that of an electron and equals to 0.51 mega electron. Mu meson or muons. So these may be positive or negative. Mass of the meson is about 207 times the rest mass of the electron, and they decay into electron or proton and neutron. Hadrons is divided into subtopics like meson and k-mesons. So mesons, pi mesons or pions. These are discovered by Powell, and these are also called as a primary meson. These may be positive, negative, or a neutral. These are represented as a pi plus, pi minus, and a pi 0. These are unstable, having life type 10 to the power minus 8 second, and spin is equal to root 0. K meson or chaos. These particles are a positive and negative or a neutral. Mass of the particle is a 966 times mass of the electron. And half life is equals to 10 to the power minus 8 second. Spin is 0. Pi minus and kaons are antiparticles. Quark. Nucleons are composed by the tiny particles called as a torque determined by scattering experiment. These are several different types of a quark, all carrying electric charges plus minus e by 3 and plus minus 2 e by 3. Proton and neutrons are no longer elementary particles since they composed of a quark. Now let's move some questions. A particle having no charge at almost no mass is called as positron, neutron, electron, neutrino. The correct answer is a neutrino. The elementary particles heavier than nucleons are meson, neutrons, hyperions, leptons. The correct answer for this question is hyperions. How much times? 966 times greater than. Pair production. Conversion of photon energy into mass. So when energetic gamma photon falls into the heavier nucleus, it is absorbed by nucleus and pair of electron and positron is formed. This phenomenon is called as a pair production. Like h nu is the energy which we are saying gamma photon when it breaks. So two things forms. One, electron. Second, positron. Controlled nuclear thermoreaction, photons and nucleus. When photons strike with the nucleus, electron and proton will be combined. An electron have some energy, which is called as rest mass energy plus its kinetic energy, which is m naught c square plus kinetic energy. Rest mass energy of each electron or a positron is 9.1 10 to the power minus 31 into 9 10 to the power 16, which comes 8.2 10 to the power minus 14, which is 0.51 mega electron volt. Hence, in pair production, the minimum energy of a gamma photon must be 1.02 mega electron volt. If E naught is less than 1.02 mega electron volt, it is called as a Compton effect. If E is greater than 1.02 mega electron, then extra energy will become kinetic energy of the particle. If E is equals to 1.02 mega electron volt, the kinetic energy of the particle will be K electron is equals to K positron, which is equals to E minus 2 E naught by 2. Controlled thermonuclear fusion. Let us see what are the thermoneutrons and their importance. Neutrons having kinetic energy is approximately 0.025 electron volt that are called as slow neutrons or thermal neutrons, which is urine 235 undergoes fission only bombarded with the thermal nuclear neutrons. When fusion is achieved by raising the temperature of the system so that particles have enough kinetic energy to overcome the Coulomb repulsive behavior, it is called as thermonuclear fusion. And this natural thermonuclear fusion process in a star is replicated in a thermonuclear fusion devices. In controlled fusion reactor, the aim to generate steady power heating the nuclear fuel to a temperature in the range of 10 to the power 8 Kelvin. At these temperatures, the fuel is a mixture of a positive ions and electrons plasma. The challenges is to confine this plasma since there is no container can withstand such that high temperature. The thermonuclear fusion is a source of energy output, then interior of the stars. This interior of Sun has temperature 1.5 10 to the power 7 Kelvin, which is considerably less than estimated temperature required for fusion for the particle of average energy. Clearly, fusion in Sun involves proton whose energies are much above average energies. This fusion reaction in the Sun is a multi-step process in which hydrogen is bombarded to helium. So thus fuel in the Sun in hydrogen is its core. Nuclear fusion reaction occurs at very high temperature of the order 10 to the power 7 Kelvin. At this temperature, no container withstand. Therefore, controlled thermonuclear reaction can't be conducted in a laboratory. Now let's move some questions. Neutrons having energies, kinetic energy is approximately 0.2025 mega electron volt are called as. The correct answer is both B and C. Nuclear fusion reaction occurs at very dash of the order of 10 to the power 7. These also known as thermonuclear reactions. Absolute temperature, higher temperature, low temperature, or none of these. The correct answer for this question is a high temperature. So this is all about for today's class. I hope you like the session. If you have any doubt, student, you may ask in the chat session. Till that, thank you for watching this video and take care.